So, thank you for your patience. We had a few hiccups this morning. We're ready to begin. What you see is the item analysis of our 1.5 assessment in Module 1. And what I'd like to do is spend a little quality time to explain what some of these details mean. And then we'll go ahead and walk through the items on the assessment that pose the greatest challenge for students in their first attempt of the Module 1 assessment. At that point, after class at 10:50, I will post the reconciliation. And if someone would help remind me to cover what the reconciliation is about after we're finished, we'll go ahead from there. So essentially, Blackboard has a set of algorithms that it uses to analyze student responses on assessment items. And it does not account for certain scenarios. Mastery learning is one of them. So if we have a case where students have reviewed and applied and understand a concept or a method so well that they all answer correctly and they all answer in the same way, it will say that it cannot calculate whether or not the question is a good question or a bad question or whatever, because it can't discriminate between student answers, right? It's actually a good thing in terms of mastery learning to see more cannot calculate poor questions, provided everybody's answering the same way correctly. Now, if everybody's answering the same way incorrectly, that's not a good thing. So that helps us refine some things. We go back and we review a little further, that kind of stuff. Any questions so far? So discrimination is helpful, but it's not an indication necessarily that something is wrong, even if you see poor or cannot calculate questions. It's this difficulty criteria that is actually more of an interest for me as an instructor, because we don't want too many easy questions. We don't want too many hard questions. We want a mix. So it's okay if we have them spread across the board. We have a few easy, we have a few hard, we have a few medium, but it's really more of a desire to be moderate in our difficulty, right? So we don't want to overwhelm people. If we're clocking medium questions in terms of difficulty, that's kind of a sweet spot. And the fact that we have 14 medium questions and 2 easy questions, I'd prefer if we had no easy questions and a few hard questions in the mix. We might see a different mix by the time we get to the final version of the Module 1 assessment where you're completing the retake. What we'll do here is look at the assessment items and pull each one up. And what we've done is sorted this column because basically each of the questions, there were 16 attempts and there are 16 questions. They're typically worth 1/4 of a point each, because the total is 5, and there's typically 2 extra credit questions worth half that much, okay? So you'll get 14 or 15 on average. You might get as many as 20 or 21 questions, depending on the amount of content in a module. What you'll see is that the average score is a 3 out of 5. So if the score that's attainable, if everyone gets, all the items correct, 3 out of 5 is what, as far as a percentage? So 3 divided by 5 is a 60%. And what we'd really like to see is most everyone log a 70. So the goal is to finish the review of a module and to work the assessments and solutions. And one thing I noticed is that some students took the assessment without completing the assignments or the solution. And this could be a factor in why the class is scoring a little lower. But that's all we'll comment on for now. The good news is when you reconcile, everybody gets, a point higher, which is 10%, or it's actually 20%. So if you reconcile this, everyone in the class reconciles for an extra point. Now the class average is a 4 out of 5, right? So the initial round of scoring and credit that's logged is higher because we corrected our mistakes. When you retake the assessment with your final attempt, we should be seeing max scores. There will be no extra credit in the final version. but there is extra credit in this one. So technically speaking, if everybody got every question right, completely flawlessly, we'd see a class average of 5.5, right? A little higher than what you could get because we're scoring correct on everything. What I'd like to do is pull up each question. You'll notice that the question types are here. We're looking for items that have poor average scores. If we could get a 0.25, this means that about two-thirds of the class didn't answer correctly. So we're going to start with the ones that are the greatest challenge. Multiple choice item that posed the greatest challenge for all students reads, a laser used with a recordable CD burns tiny pits in the surface of the media to represent which binary value? And the answer is 1. The presence of a pit means 1. The lack of a pit means 0. So if there's no pit, it's 0. If there's a pit, it's a 1. And that's oversimplifying things. But it's also true of magnetic metal platters on a traditional hard drive that are spinning. You'll have a magnetic mark or a pulse in the metal media and the magnetic coating on that metal disk. And we'll examine hard disks in quite depth later in a following module. But more students answered this by saying 0, right? So a pit visually seems like a 0, like there's nothing there. So what you have to remember is that the computer has to recognize positively something that represents a 1. So the burn mark is actually not the absence of data. It is literally the data, okay? And that's, again, in this course, we're kind of taking on new concepts and new ideas. Any questions about this first item before we move on? We're going to move pretty quickly on the remaining items. You'll notice that when we get down a little further and we get into the higher values for like true, false, and multiple choice, if it's close to a quarter point, we're just going to keep rolling. The multiple answers are supposed to be about a half a point to 3/4 of a point. So if you see this value, that means, yeah, wow, a lot of folks had a challenge there. Next question is multiple choice. It reads, the Boolean hexadecimal value BAD is doubled without using a calculator. The binary value is shifted one place. It's shifted one place, and the result to do that doubles the value. Does everybody catch those hints? So are we moving to the right or the left when we shift, if we're doubling? Anyone?
Left.
Where shifting to the left is correct. And if you basically do the same steps in the worksheet, what you'll find is that you're shifting to the left. Now, one of those answers results from putting a 2 in front of there and then getting the binary value. So how do we calculate this to check it? This is an open source, open book assessment. Allow me to suggest that for your next assessment, you do the manual process, but check your work. It's okay to do this, to check your work, but you want to be in the habit of working the manual calculations, right? So you go to Programmer Calculator. Everybody see what I'm doing? I select hexadecimal. I type in BAD, and that's the binary equivalent. So I have the table that shows that Bravo, or B, is equal to 1011. Alpha, we already know, is 1010. If you've been memorizing that table, there should be a distinct pattern there. So I'm going to walk through this type of challenge once or twice because it's more, it has to do with the worksheet. We can't do this with each item like this, but D is actually 1101. So if you take that and you shift it 1 to the left, that means you have a 0001 and you have 4 nibbles. There's only one answer that has 4 nibbles. Does everybody see how I reached that conclusion? Process of elimination, right? Okay. If I multiply by 2, what I get is this answer. So I can actually check to see, but the first telltale sign is I'm doubling and I've got a boundary here with that that first value. So when I shift to the left, I'm taking up a whole new nibble right here. That's the only answer that has one. It's the only answer that could be. Any questions? We want you to start thinking like a computer. It's like, oh, I get that. All right, let's move a little faster. Multiple choice question. What is the factor used to multiply against the value of the hex value Charlie for a hexadecimal value of ACE? So what they're asking is, I have 3 hexadecimal values, alpha, Charlie, and echo. What's the multiplication factor, or, put another way, what's the numerical factor for its place? In the first place, we have 1s. In the second place, we multiply by 16. In the third place, we multiply by 256. In the fourth number place for hex numbers, we multiply by 4096. Right? You got to know those. You got to know those numbers. So the answer is 16 because it's in the second column. The number of students answered 256. We don't have a 256 in hex. It goes from 1 to 16 to, or maybe it does, 256. I'm sorry, I'll take that back. What's 16 times 16? What's 16 cubed?
76.
Let's go scientific. If I have 16 y to the x cubed, oh, it's 4096. Yeah, no, there are no 256s. All right, sorry, need another cup of coffee. So,
Square, right?
yeah, it's 16 squared for the seconds place,
So that would be 2.
but 256, it says this one is incorrect because it says 256 because that is the value of the seconds place. The answer is 16 is the value of the seconds place, not 256. That's why this answer is false. So you go from 1 to 16 to 4096. It increases in a hurry, right? Well, actually 4096 is the fourth value. Let's back the truck up. So when I cubed that, I actually should have, here's what I should have done. 16 y to the x to the 0 power. Anything to the 0 power is going to equal what? 1. All right. Yep. And then 16 to the first power, y to the x is 16. And then 16 squared, that's 256. So the third column is 256. So my bad. Again, my apologies. I need another cup of coffee. So 16 y to the x squared is going to be 256. And then when we're using 16 to the third power, that's actually the fourth column, because the first column is 16 to the 0 power. Remember that the first number in binary is always 0, right? So that's the tricky part. Any questions about this item? All right. So in this item, we have a multiple choice question that reads, if you shift the binary value 2 places to the left, what is the final hexadecimal value? Well, if I take this 1, 1 and I slide it once and then again, what do I have? Well, I have, what's in this column right here? Mm-hmm. Actually, am I asking for the decimal equivalent or the hexadecimal? That's what throws most people. I start thinking in decimal terms, right? So if I slide this 2 places to the right, what I have is a 0, 0, 0, 1, and then a 1, 0, 0, 0. I have 2 1s close together. So if I shift these over 2 places, this one moves to here, and this one moves to the next nibble or D word, right? So it's 0, 0, 0, 1. So what's the hexadecimal value? 1. And then what's the other value? 1, 0, 0, 0. The hexadecimal equivalent of that is 8. It's not decimal 18, it's hexadecimal 18. That's really important to understand. This is the binary value that results, but the question reads, what is the hexadecimal value? So you can't let the criteria that's requested throw you. Always remember that you're not just doing the bit shift, you're rendering the desired value in the number system specified, okay? Everybody with me? Moving right along. Or did I skip one? Similar kind of question. You have a binary value of 1110. What is the binary value for a one column bit shift left? Well, if I take this and slide it once to the left, now I have a new nibble, 0001. It's asking for the binary value, not the decimal or hex value. And I have 1100, right? So the only answer that has two D words or two nibbles is the first one. It's the only thing it can be. Does that make sense? Moving right along. Now, you can request a session with me to walk through some of these. If they're taking a fresh look at it and you still don't get, okay, how did we get that answer? We're going to keep going until we get to this item here, and then we're going to skip over. Actually, we'll roll to this one here. Most everybody got these two correct, and then we'll jump down and do the last 4 multi-answer items, okay? So the true-false question, this might have been extra credit. It said when a circuit is closed, that means the electricity is flowing, that means the light bulb is on. So what's the Boolean value? True. Boolean value is true. If the circuit is open, the light bulb is off, which means it's 0, okay? Does everybody understand what I mean by circuit? There's a little wire with a light bulb kind of thing, okay? The value of C, multiple choice, says what is the decimal value of hexadecimal character C when it is used in this hexadecimal number? Well, when I'm using C in that hexadecimal number, I'm multiplying that decimal value by what factor? Anyone? It's 12 times 16. So Charlie equals 12 in decimal, but because it's in the seconds column, it's 16 to the first power. So I'm multiplying 12 by 16. 12 times 16 is 192. That's the answer. Any questions? Okay. F, right? F. Those are all ones. F is 4 ones on that table. So in binary, we have 1111, 1111, 1111, 1111. You notice the network tool that a repeating pattern of hexadecimal characters are shown on the screen. What can you correctly conclude about this? The pattern is 2 bytes with 16 binary 1 values and no 0 values. The reason it's 2 bytes is because it takes 2 nibbles to make a byte. So if I have 2 nibbles here and 2 nibbles there, I have 2 bytes. I have 2 8-bit segments, 4 by 2 each, okay? And it's all ones. That is the answer. Any questions? What is CAD? Does anyone want me to continue with these 2 items here? Does anyone want me to show these 2 items? Most everybody got those. Or this item. We actually did CID. No, we didn't do this one. Yeah, I really need that cup of coffee. Okay, multiple choice. The Boolean hexadecimal value CAD is doubled without using a calculator. The first step is to convert each hex value to its binary equivalent. What is the binary value of CAD? Well, C is what on the table?
12.
See, it's asking you to read from the table. That's all this question is asking you to do, is to go to the table with the hex and binary values and give the binary value for C, the binary value for A, and the binary value for D. That's all you got to do is look it up. C is 1100, A is 1010, and D is one more than C, so it's 1101. Okay. Everybody see that? All right, let's look at the multi-answer questions, and then we're done for the day, and I'll post the reconciliation.
Professor?
Yes.
Yeah, actually, I forgot that we went past it, but I forgot to just ask about the true and false with the closed circuit. I'm just a little confused because in your study guide, when it talks about, Boolean, true, false, you have on, off, yes, no, true, false, open, close, and 1, 0. And I thought that the 1 and the open were like.
That's a really good catch. I understand what you're saying.
Yeah.
You're saying in the study guide, I was rattling off the values, the two different polar values.
Yeah.
But because I always use the true and the 1 and the yes and the so on, the assumption was open
Indeed.
equaled that.
Yeah.
That would be a reasonable assumption. What we're going to do, I'm glad you brought this up. What we're going to do in this class, one good thing that we do during item analysis is if we discover that there's a discrepancy that caused a greater number of students to get it wrong, we'll go in there and we'll give credit for people who answered incorrectly on that basis. So would you mind sending me a quick email? And then what I'll do is I'll publish a correction to the study guide so that it reads closed open instead of open closed.
Right.
And then that way it's consistent.
Yeah.
And then that way it won't throw. That's really good. I'm really glad you shared that. So we'll post credit for people who got that item wrong. And we'll also post a quick revision to the study guide to make sure that we're not throwing people off. Good catch. Thank you. Yeah, just send me a quick email that says open, close.
No problem.
Open, close. And that's also a bounty. So, we post additional credit for people who pick up on stuff like that. If you're troubleshooting an item on an assessment and you catch it, we're glad. It's a team effort. I'm crowdsourcing my students to catch my conceptual glitches here. So, and I'm going to blitz these last 4. So a computer science student attempts to decrease, that means we're shifting to the right, to 1/8, that means we're going 3 places to the right, by shifting bits to the right 2 times. Uh-oh. So 8 is a 3-bit shift, not a 2-bit shift, but the computer science student is they're going to the right 2 times. That's only going to generate 1/4 of a change, right? However, this method fails repeatedly. Please select all the statements below that are accurate. The shift must be 3 places, not 2 places. 3 binary boundaries result at the leftmost boundary. The shift must be to the right, not to the left. Did we say he was shifting to the, oh, no, that is a correct statement, even though the student was doing it correctly. So those are correct statements. And the question reads, select the statements that are correct. The only 2 statements that are incorrect are the last 2. Any questions about this multi-answer item? Moving right along. A computer science student attempts to increase the hexadecimal number 1 foxtrot. 1 foxtrot is binary, in binary terms, is 0001 1111. Does everybody get that? 5 ones in a row. We want to increase it 16 times the original value. So what we're going to do is we're going to shift that how many times? trying to shift it to the right 3 places. Well, if they're trying to increase and they're going to the right, that's the first problem. If they're trying to increase 3 places, that's only changing it by a multiple of 8 instead of 16, right? It says, however, this method fails repeatedly. The shift must be 4 places, not 3. 4 binary zeros will result at the rightmost boundary. So if you actually take one foxtrot and you shift it 4 places, you'll see this result is true. This result is true. So you select that one. It says the shift must be to the left, not to the right. Those are the 3 answers that are supposed to be selected. So when you reconcile, you're going to say, I neglected to select this answer. I chose, I should have selected this answer and this answer. I should have avoided, I should have avoided selecting this answer, right? When you reconcile. Next to last question here. Select all that apply regarding hexadecimal characters used to represent binary digits. 1 hex value represents 4 bits, which is 1 nibble. 2 hex characters represents 1 byte, which is 8 bits. Those are the 2 correct statements. The other ones are false. Any questions? Last, multi-answer question. Select all that apply regarding the binary values used to represent a hexadecimal value. There are 4 binary digits or bits used. Yeah, that's correct. You preserve leading and trailing zeros, right? Calling them a tuple or 4 bytes are 1/2 of a bit. No, 4 bits are 1/2 of a byte. Those terms are reversed. So that statement is false. I see 4 students chose that answer. All right, so when you reconcile, what you're doing is taking you're typing the words of the question, not copying and pasting. Do not copy and paste. And you can use your own words. You don't have to write it. You don't have to type the words. You can type it in a shorter statement and it still means the same thing. You'd say, the question reads, a laser used with recordable CD burns tiny pits. The correct answer is 1. What we want you to do is to type out with your own hands the words of the question and type out with your own hands the correct answers. That's all you're doing for reconciliation. You'll see when we post the assignment. Any questions before we close for the day?